All right. Good morning. Welcome back. Day 3. We're going to hit the halfway point, kind of mid-morning, right? So, yeah, we're going to cruise on from there. We've got lots of stuff planned and lots of stuff going on. I'm trying to make sure I get all of the pages where they need to be. Close that down. That one's there. All right. So first of all, I mentioned this right before we started recording, but I did not upload yesterday's videos. I just literally finished rendering the afternoon video right at the beginning of the class. So I will try. I'm thinking maybe lunchtime. I'll try to push that up so it'll go up while we're not, here and doing things. And it usually doesn't take an hour to get uploaded, so we should be in good shape there. So you'll see day 2 afternoon show up in the playlist this hopefully at lunchtime, and then this evening I will try to get yesterday morning's and then today's stuff done. We are praying that we don't have any kind of weird disconnect issues that we had yesterday. So hopefully we can avoid those today. If we do, right, sit tight, I'll get back on and we'll keep on trucking, but hopefully we don't. All right, so that's the first thing. The second thing is just a reminder of the G drives, the Google drives. You're welcome to push stuff up here if you would like. I did add a Linux cheat sheet that John provided. So pretty cool ultimate Unix Linux command cheat sheets, right? So lots of cool stuff going on here. So I think part of being a good cybersecurity professional is being really good at the command line in the terminal, whatever you want to call it, right? This will go a long way to help you do that. So thanks, John, for that. The other thing I do want to point out, we do have this workshop, resource web links. It is not I control this document and whatever I put there is law. Like if you have links that you would like to share that are appropriate for what we're talking about and what we're doing, please copy them up there onto this document. Okay, so this is kind of a shared document. And the idea of this is that once we're done, right, you can revisit this document and kind of explore the links and the web links and whatever else is being shared. Right, so don't forget that you are all editors on this particular document. So it's not a top-down kind of a thing. All right. I leave this one up in the browser so that you know that this one is in if you go to the Cisco IoT course folder that I shared, there's an IoT course issues page, and this is where I'm going to leave this up. So when we run into issues, I think hopefully the keyword is when we run into issues, we can put those issues on this document so that in future, right, if you're doing IoT and you're pulling these courses, you can look at this document and have a good idea of how the lab is going to go. Right. So one of the labs that I've chosen for today, using Las Vegas terms, it's going to be a crapshoot, right? It's going to be, I don't think we're all going to get the same results. We may get some successes, we may get some failures. I do think the whole lab is probably going to be an unmitigated disaster, but I want to do it anyway. And I'll explain when we get there why. So, this document helps me know that, hey, this is going to be a problem. So that's good. The next document that I want to share with you is, this is from Docker. And I believe when I got to this, it was like, here's all of the Docker containers that work on the Pi, right? I'm not a Docker expert by any stretch of the imagination. I think you saw my Docker expertise yesterday. That was about it, right? I have done a couple things and I followed some labs, and I've done now Docker on the Raspberry Pi, and I've done Docker in Windows, right? So Windows Server can host a Docker solution as well. And but I'm like, man, I know there's other stuff. And then it come out here, and if you search, the search was like Docker containers that work on Raspberry Pi, and then there was a link that's, here's the, and there's 157 results here, but like MySQL, Who Am I, Redis, No IP, BusyBox, right? So InfluxDB, here's the Portainer one that we're using. There's a ton. I don't know what to do with any of them. What I am so excited about with this is that there's a bunch of cool stuff that we can actually then run in Docker, right? And we can run them as containerized applications. Even one of them is Python. So I think you can actually run Docker and then drop that Python container on it. And then you can, you connect to that container and you can actually, do Python coding just like in a container, like, and you can actually run that as multiple things on a computer. Now, the practical use of all these things, I don't know yet. I mean, it's cloud solutions. Like in a lot of the things that we work with containers, there's going to be like connecting with AWS and doing, containers there. But I think it's neat that we can actually maybe start building out things here locally. And I know I've repeat myself a lot, but there are currently, I think I saw 2 or 3 different capture the flag setups on Raspberry Pi that are all containerized. So I think it's something that you don't really want to ignore. Maybe you want to start kind of figuring it out. For me, it's on my list of things I want to start figuring out. I like the fact that I can do this on a Raspberry Pi. All right. So that's the first, and I should copy that one into the web links. All right, so we're going to drop down here and do a day 3. And then we'll drop that one there. All right. And the only other website I want to share before we kind of get into classwork course material is this website here, or this article here from Make Use Of. We're going to then copy that one over as well. And this article is cool. 8 ways the Raspberry Pi can help you learn online security skills. Right? So I think this is fun because they kind of point out to other people's projects, right? But Kali Linux, right? So we already know, like we're running a Kali Linux VM. I've mentioned on first day that you can install Kali Linux on a Raspberry Pi, so that a student could use a Raspberry Pi with Kali Linux on it and do pen testing and learn cybersecurity skills, right? So I think this is a totally cool option there. The next one, I almost want to build one of these. I had never even heard of this. It's the USB sanitizer, right? So you turn a Raspberry Pi, and this is an old Raspberry Pi, which I think would be a good way to use a Raspberry Pi 1, Mike. But these are, you basically can plug in a USB into this, and and if you've done all this stuff right, it will actually go through the drive and make sure there's not any hidden malware or viruses or anything like that on the drive. Like it's a sanitizer before you plug it into a regular computer, right? Because that's a common way for viruses to be spread, right? You drop them on a thumb drive, right? I think, and I mentioned Mr. Robot the other day. That was one of the hacks that they did. They kind of tailgated in during lunch. If they're into lunch, they dropped a couple of USB sticks on the main table there. Somebody picked it up and plugged it in their computer to see what was on it and infected the network. Okay. I think it's also the same way that if I'm not mistaken, right, the Iranian nuclear facility was hacked that way, right? Somebody bought a USB, if my recollection is correct, right? Somebody bought a USB thumb drive at a local market. One of the guards did, and plugged it into one of the computers inside the facility, and then that spread the virus. That then destroyed the centrifuges. Okay, which is interesting because, right, there was policies against that, and right, IT should have probably disabled all those ports if there was a policy against that, especially in a nuclear facility. But so that's something that we should be. So I think this is really cool. This is me getting sidetracked again. Like, this is a really cool project. I think I would love to try. Maybe we can probably try to pull that off this week. I don't know. That one's really neat. Now this one, I think it'd be fun to check it out. I'm not sure I'd want to share it with students. I'm sure they'll find it on their own, right? But Poison Tap can infiltrate any computer even when it's locked or password protected. So yeah, so I'm not sure that this is a project we want to do in class. I think it would be a project that, you know, as a cybersecurity professional, you'd probably want to see how this works. Maybe build one so you understand what the process is and that kind of thing. But I wouldn't want. I'd be afraid of showing this one to students. But anyways, it's there. Make an ultimate honeypot. So there are a couple of projects that I found online that I think are really neat, but you can set up a honeypot, right? And that, you know, a honeypot, we could use that in the classroom to show as people do port scans, and, you know, as they get kind of, you know, they think they found something, and then they get kind of snared inside of that. So that would be kind of a neat deal to do. Facial recognition with OpenCV. So, right, well, you know, I'm thinking, you know, first thought is like, well, how is that cybersecurity? Well, right. Physical security is also part of cybersecurity. So you could easily create you know, an OpenCV facial recognition system that helps, you know, as a double check for opening a door, unlocking a cabinet, whatever the case may be, or entry into a specific space. So it'd be fun to do that. Or I think these projects are cool. Nagios network monitoring, right? So Nagios, I know that we can do Nagios because we've done it in the previous course. I think we did in the networking, or the Raspberry Pi networking course that we've done. We've done the Nagios installation. So if you want to set up kind of a network monitoring solution and show, I mean, because that's also part of cybersecurity, is monitoring your network and seeing what's there and what kind of devices are there and what kind of traffic is being pushed across your network. And, you know, is that the kind of traffic that you expect to be there, that kind of thing. So that's another really cool project. Like this article alone, like we could build this entire weeks on this article, the week's worth of labs. Create a Pi-hole, right? So Pi-hole is an ad blocking solution that you can build on a Raspberry Pi. We have built that one also. I think we built Pi-hole and Nagios in the same class, the networking class. The last CIS course that we did 2 weeks ago, we did an alternate to Pi-hole. We did AdGuard. It's not as flashy, but it does the same thing. It also comes with like DNSSEC and like HTTPS and DNS security built in. Like, so it's going to do all your DNS queries are encrypted. So there's some really cool. That's an ad blocker, right? So again, I think if you're thinking cybersecurity, right, we want to protect our network. If we're blocking ads, then we won't have people clicking on things that they really shouldn't be clicking on and going places they really shouldn't be going. So that's something that, again, another really cool lab that can be built around that. I know Pi-hole and this one, Nagios, are both Pi My Life Up has a really good deal for that. Oh, and then look, Mr. Robot, right? So, to destroy Evil Corp, I'm not sure what this one is, right? So I'm trying to see if there's read the tutorial, learn how to make it. Okay, so there is something here. Citrus doesn't give the idea of how. So right, no byte user. Okay, so that is. So that's another, looks like another device that you can use you can turn your Raspberry Pi into a device that allows you to connect to a system. And I don't know if have any of you seen Mr. Robot? I had read articles about Mr. Robot, right? And one of the interesting things about it is that they had a technical, like the cybersecurity technical expert that they had for the show, like insisted that, you know, if they're going to do the hack and they're going to show it on video, that it needs to be like, it has to be done in that amount of time. Like it has to be done when you can see it. The only time where they, and so it caught my interest. Like, so when you're watching these things, like they actually do these things in real time, in a way that it could be done in that time frame, which I think is really interesting. The only time, like I think early on in the show, he hacks a password, right? So he learns the guy's dog's name and things like that, and then he does a password hack. But they show they kind of go like dark and he's talking, so they kind of give you the sense that there's a lot more time going on than just this 5 minutes of me hacking his password. But I think all the physical hacks that they did, they meant to do them in real time, like it had to be capable of doing them in that way. So I think that's an interesting way, and this is just this is a project that would be related to Mr. Robot, and then your students could watch Mr. Robot, and then there's relatable content there. So I think it'd be interesting. And then they talk about just homegrown security and some other things. So, but I think that's a really good set. Like this is 8 like very interesting, very relevant cybersecurity related projects, all being done on a Raspberry Pi. Right? 7 of them are probably like, we could probably pull it off in a regular classroom. I think I'm just sure that we should do this one in the classroom. But I wanted to share that with you. The link is on the workshop resources, right? So make sure you check those out, go explore those on your own. If you see something, and maybe we can try to pull one of these off if enough people are interested, and maybe we try to pull one of these off tomorrow. That'd be kind of fun. All right. Cool. So then the course, all right. So then the plan, our plan for today, I wrote it down today. We're making progress against right, as we do things, right? So we're only 1 session behind, right, from my optimistic scheduling. So that's pretty good, because usually by here we're only got like the first day done. 3215, that is the device hardware lab. We're going to do it on Friday. So if you have a cable coming, great. If you don't have a cable coming, that's also great. You can just hang out and watch and see it. We're going to record it. You can get a cable later and do the lab yourself. But that's the one where we compromise the device hardware. That's where we're going to create a terminal connection to the physical GPIO pins on the Raspberry. And I think for me, that's like one of the critical labs that I wanted to get done this week. So we absolutely will do that on Friday, because it is a Raspberry Pi specific, cybersecurity, physical pen, hacking project. Okay. So that one. The next one I had slated on my original agenda to do this compromise and IoT device firmware. Okay. Now, let me show you the lab. I'm going to tell you we're not going to do this lab in this space, right? Because this lab is a log into the Kali virtual machine and do a whole bunch of stuff on the Kali virtual machine. Okay, we're not connecting to a Raspberry Pi. We're not, right? So I'm not saying that it's a bad lab. I really actually think it's a really good lab, but it's not Raspberry Pi focused. But I want you to be aware of it. I want you to know that you have access to this lab. You have access to your Kali Linux. You can absolutely do this lab on your own. I don't think we've had any. I don't think we had any issues with that one. Maybe right here. So USB, nope, that's nothing, right? So there's nothing here. So, so I'm expecting that if you wanted to do that lab, that you could easily do this lab on your Kali Linux box at any time in the evenings this week or next week or 2 weeks or a month out from now. The class is open until like late September, right? I left, so plenty of time for you to explore. There's no pressure for you to do the lab. I just want to concentrate on Raspberry Pi focus labs, right? Because that's kind of the whole gist of this workshop. So if that makes sense, I'm hoping that makes sense. Hope you're not disappointed with that decision, but that is what we're going to do. Okay, now that moves us on to the next 2 labs. So 4.123. So we are going to do Bit Warden first today. That we're going to finish up the Bit Warden. It's right up here, right? I just want you to have a plan, an idea in your head what we're going to do. We're going to do Bitwarden. Based on, reviewing it yesterday, I don't know that it's going to take us a whole lot of time. It'll take some time, and probably a good portion of the morning. The next lab I want to do is the Sniffing Bluetooth. Okay, this is the lab that I fully expect to fail. Right? I fully expect it to fail. So we all want to know that going into this. Like, it may not work, it may work. Right? We may get some results, we may not get some results. That is based on a previous, right? This lab was all over the place, zero predictability for outcomes, even when the directions were followed. Some people found their phones, some people didn't. I found it, but couldn't connect. Like, there's all kinds of crazy things. So you're going to use the Raspberry Pi to find Bluetooth devices and try to connect to those devices. I don't know if you've played with Bluetooth, sometimes stuff works and sometimes stuff doesn't. And then when we're doing without, kind of using proper keys and stuff like that, like, maybe it works, maybe it doesn't. I think it's worth the time to try that lab. One of the interesting things that I get out of that lab that I think, I would like my students to see is, hey, this stuff doesn't work all the time and it's not easy. So this is one of those labs, right? This is a lab where you're like, I can't get it to work. And it's like, this is so hard. And or maybe you're like, it worked perfect the first time, no problem. You're going to get hit and miss across the board. So
is that lab needs just a regular Raspberry Pi or is it a PL app? You do that on the PL app?
Let's look. Usually this is a PL, this is a PL app Pi, and it's probably, probably a PL app because there is, there may be, Bluetooth service. You may be able to get away with a regular one because Bluetooth is on all of these. We could try it on a regular. I don't know, like maybe this exists on your machine, maybe it doesn't. You could install it. We could try that. So if somebody wants to try it on a regular Raspberry Pi, we can try it. Because I know Bluetooth is built in, like the Bluetooth, the service is built in. I'm not sure about Bluetooth CTL. I would imagine that Bluetooth CTL is there as well. So this is just getting us into Bluetooth stuff. I can't imagine that this wouldn't work on a regular regular Raspberry. We could try it on both.
Okay.
Yeah, so that may be, we'll try it on both, and if it works on a regular Raspberry, then that's a lab that you can pull out and take to class now, right? So I don't know. It's one of those, I want you to be aware ahead of time. I fully expect it to fail, so there won't be any, sadness if something doesn't work on that one. We're going to try it. I want to try it. And then the last lab that I have planned for today would be port scanning, right? So that's going to be using Kali Linux to port scan the Raspberry Pi, which we've done a little bit of that already. This one gets into a little bit more detail. So I think that's a completely appropriate lab for, exactly. I'm not going to be destroyed if that doesn't work. So, and then port scanning. So I think it's going to be a fun day. Like, I really do. I think we're going to finish up building the Bitwarden that we started on yesterday. So password manager, a self-hosted password manager running in Docker on a Raspberry Pi. I just think that idea is just really cool. And then Sniffing Bluetooth. We're gonna attempt that one, and we're gonna do a port scan. And then if we still have time, we can grab and we'll go back to our pile of, maybe that's where we start looking at that Bluetooth scan, or that the USB, cleaner thing or something along those lines. We can pick something at that point if we have time. So that's the plan for today. I hope that excites you. I hope that's going to be fun. I'm looking forward to it. So here we go. Anybody have any questions, any comments, any issues, anything? Before the end of the week, I saw this setting up a Raspberry Pi Wi-Fi, and it reminded me because there's another project that I really wanted to try. It uses a software called Kismet and does wireless and Bluetooth scanning. But the lab reminded me that you have to get a Wi-Fi dongle that allows promiscuous mode in order for that to be able to do that kind of project. You can't use the onboard Raspberry Pi wireless to scan, like to do network scans and things like that. But you can plug in an external USB wireless, which I think we had picked up a bunch for like $10, $15. So we're not talking an expensive one. We just have to find the right models. So I'm going to put that on my research list. Wi-Fi modules that allow promiscuous mode. All right, awesome. But I thought about that as I saw this one over here. Cool. Let's take a look at this Bitwarden. So we've got Bitwarden. We went through and we did the Docker setup. We did the Portainer setup. Docker directly. So now that we've prepared the Raspberry Pi, we can move on to installing Bitwarden software. As Bitwarden RS is available as a Docker container, the installation process is straightforward. We've written 2 guides. One that will show you how to use the Portainer to install the Bitwarden, and one that will show you how to install Docker directly. So using Portainer, because we've set up Portainer. Here's our thing from yesterday. And I know that's just me as a system administrator wanting to have an interface that I can manage this by. So we'll see how it goes. So preparing, so let us know for Portainer so we can install the Bitwarden. So we're just going to move right to this point here. I'm going to put the link, right? So the link to the lab is in the chat. And there's several sections, but underneath using Portainer to install Bitwarden. And we're going to go prepare for the Bitwarden container. We'll just start right there. Right. To load the Portainer web interface, right? So, and that's what we've done here. I've just typed in my IP address :9000. Right, to get to the, I wonder if we got to log out and log back in. It should probably do that. Let me log out of this. I left it running. So I don't know if there was a timeout issue or what, but.
What do you want?
All right, so I logged back in. It looked like my session expired. So maybe I'm hoping that that's what the cause of those warnings were. Okay. So I think our best way of doing this is moving all this mess out of the way. Putting that there, putting that there. Okay, so on the right-hand side, I've got the instructions. On the left-hand side, I have the.
You want to go out?
I have the Portainer, and I'm double checking to make sure. Okay, I am recording. All right. So then, when you load up the interface, you need to change the local Docker endpoint. Click this endpoint so we can manage the containers available on it. So we click on the endpoint. And before we can create the Bitwarden container, we need to make a volume for it. So in the sidebar, so I can bring the sidebar open here. There's volumes. Okay. So we need to create a volume so that we can create this Bitwarden container. Within this menu, you see the list of volumes we've created already. Right? So we just have the main volume for Portainer. Okay, at the top of the list, we'll see add volume. So we're going to click the add volume. Well, yeah. So click that. We need to choose a name. We're going to call it Bitwarden. All right. Once you've chosen the name for your Raspberry Pis, click create the volume. So we're not going to do anything else here. We're just going to say create the volume. So now we have an unused volume that we've saved out for Bitwarden. For the volume created, you need to change to containers menu. So we go over to containers menu here on the left. And then we're going to add a container. Number 7, add a container, which is, it's been stacked here. So add a container. Now that we have done the initial preparatory work, we can deploy the Bitwarden container. So just click add container. So that should leave us right here, right? Create a container. So the name is going to be Bitwarden. And the image I'm going to copy this out here. No, I'm not copying over the exclamation points. So I just have, it's interesting. This one says enter Vault Warden, and down here it shows Bitwarden. We'll see what happens. Normally, this is the second time on this instruction that we've seen this, where they like this doesn't have the right thing that matches here. I'm going to go with what they have up here. I think they may have updated it. I'm going to hope it works. If it doesn't, we'll come back and we'll change that. We'll just do a new one. Next, we need to set the network settings. Okay, so look for network ports. Configuration header right here. Underneath this header, you will click the publish all exposed network random posts. Publish a new network post. I'm not seeing, I see publish all exposed network posts to random host ports. Manual network ports hosted. So slightly different. It changed the way this looks. Click publish a new network port. So I'm going to go with, I guess, I don't think we have to do it twice.
I think there is a plus sign. You have to click on it.
So here, maybe?
Yes.
They want us to do that? Okay, there you go. All right, so that's a little different, right? Manual network port posting, publishing. Cool, all right. Okay, so 2 sets of boxes. We would have probably gotten there at some point. Set all the ports we want to expose to Bitwarden. So first box, we need to set both the host. So this is the first box, and they want us to do 127.0.0.1/8080. You also need to set the container to port 80. This is the port that Bitwarden's web interface will be accessible from. And I think it's just, we just put the port number in, looks like, right? Yep, looks like. So the first box has the host using 8080, and we're going to point that to 80. And then the second step will require you to set host to 127.0.0.1. We're going to use the port 3012. And the container port should be 3012. Utilizes this port for WebSocket connections. Should note that we have bound both of the host ports to the local device. Yeah, I mean, that's okay. The reason for this is we don't need external devices to access these. Instead, this will be exposed using the Nginx reverse proxy. So we've set this container just to be on the local host, and then we're going to use other products to push it out. Okay, scroll down to the bottom of the page until you find advanced container settings. Advanced container settings. So far we've got name. We're using Vault Warden because I'm hoping that that's okay. We've set the ports on the network. We're now down to advanced container settings. There should be volumes. There's volumes. And we're going to map an additional one. And we can select, right? Can we select volume? No. So the container /data. And then Bitwarden local. All right, so that's that volume that we created a little while ago. Next, we will want to make sure Bitwarden is kept online on the Raspberry Pi. So do the restart policy right here, restart policy. And I believe they want us to set to always. So we'll try to keep the container online if it fails for some reason. Under actions, where's actions? Once you finish, we can finally deploy.
It's right above there. No, scroll down all the way, and right before advanced container settings.
I'll deploy the container.
Right.
Okay. Oh yeah, there it is. Oh, actions. Man, they made that hard to find. Okay, deploy the container. So then it's going to pull. It's got to go through its thing and pull all this information. Once Portainer finished pulling the Bitwarden Docker image from the Raspberry Pi, it will become available on the containers list. Below is a screenshot of our containers list after finished setting up Bitwarden. Okay. So deployment in process here. We're going to need to play with this a little bit more. There we go. So Bitwarden, it flipped over to the containers list and Bitwarden is starting. We don't need to worry about installing it with CLI. But here is the next piece, setting up Nginx proxy. So we'll wait for this to be running. So even though it's up and running, it isn't impossible to use it until we set up HTTPS. This is because Bitwarden's web interface uses a certain JavaScript function that browsers only allow when running an HTTPS connection. All right, to support this, we're going to set up a proxy Nginx. It will sit in front of the Raspberry Pi Bitwarden server and proxy the request. Okay. Oh my gosh, we have another install video. Do that when you install web server. Okay, so we're going to set up Nginx and a certificate. It looks like. So we're getting into all kinds of security things today. Already, it's not even 11 yet. Okay. Okay, so then I'm going to. So we're going to go do this, and then we're going to come back here, and we'll go through the rest of this process. So this is a more complicated than I was thinking. All right, build your own Raspberry Pi Nginx web server. Okay, so it's a better alternative to Apache for a few different reasons, right? So this is just somebody's opinion. Much lower memory usage, generally lower CPU usage. Right? So that's not a bad thing. Okay, so we need to install. Let me go back here and make sure it doesn't. So follow the guide to install the Raspberry Pi. You only need to follow the first section, as PHP is not required to operate the proxy server. So I'm glad we came back because we would have trucked on through the whole thing. So we just need to do the first section of this. So we're going to then, we need to SSH. So I'm going to leave the Portainer running here. And we're going to SSH to, well, let's SSH to the drive, not to the computer. I do not have So it's a great question. I don't have ads on my Pi My Life Up because I subscribed to his I subscribed to it. I paid $20 a year to not have ads so that I can do these labs without ads. Because I do these labs with my students, I do these labs with instructors. And for me, the $20 is worth it, right? So I can also run a Pi hole on my network and not have ads show up either. I've done both ways. But as much as I use their material, for me, my decision was, it's worth the $20 for me. If you're only going to hit it once or twice, then, either one, deal with the ads, two, support their, just you can support them with $20, or, later weekend, probably tomorrow, do a Pi hole and you can turn on Pi hole and then never had ads either one. So yeah, I subscribed, but that doesn't mean everybody needs to. I felt like the benefit that I get from their webpage, being able to teach and using their stuff, and I cannot believe that I have not messed this up again. Oh, sorry. This is what happens when you don't use defaults. So, awesome. Yeah, because otherwise you're gonna have like a video in between every single thing. It's that kind of piece is annoying. But yeah, either way works. Okay, so I've SSH, right? Secure shell into the same machine that's running this container IO and Docker, and we're going to run through this install, this first part, setting up Nginx on the Raspberry Pi in order to access the bit warden. All right, so first command that we need to worry about is actually what we should do. Let's do sudo apps update. I'm not going to do the upgrade, I would say, because this is a brand new machine and it was updated 2 days ago. So I have 58 things that could be upgraded. So I need to do an update or an upgrade after this. But, I just wanted to have the newest list. So I'm copying over this sudo apt remove Apache 2. It's just making sure it's not there. So it says right here it's not installed, so not removed. Right. So that's just in case, it'll conflict with Nginx. So then we're going to do sudo apt install Nginx. So that's going to install the software necessary to run. We're going to do a Y there. The server. This is, yeah, I like this. I like this. Six steps and we're done. Yay. Okay, so then, right, installed. So now we want to start the server. So sudo systemctl start Nginx. So it's real similar to things that we were doing yesterday, to turn on telnet and FTP and turn off and all that kind of thing. So we should have just started it. If you don't know the host name, you can put the host name there, but we do know the host name. And we are going to go to the, we're just going to hit the website. So 172. We're just going to hit we're going to just go to the IP address and we should have Nginx, right? So we have a web server up and running. That was as hard as it gets. This is all we have. How to modify this? No idea. So, but that's all we have to do to get it up and running. Right? So then at that point, right, I'm comfortable that we have this functioning and I want to return back to the setup for Bitwarden. So we're going to just go back on my instructions here, which is back to the Bitwarden installation. And we've done here number 1, right? Install Nginx. You only need to do the first section. PHP is not required. Once it's installed, you need to generate an Ssl certificate for it. There are 2 ways to generate a certificate on the Raspberry Pi. If you plan on using a domain name, you can utilize Let's Encrypt to create an Ssl certificate. You can't generate a signed certificate if you only use an IP address as a domain name, right? So as alternative is generate the self-signed certificate. So I'm perfectly fine with a self-signed certificate for this particular experiment, right? Because we're not, but if we were going to put this out and want to maybe connect to it remotely using dynamic DNS or whatever, then we probably would want to have a signed certificate from a third party. Okay. While these are still secure, you'll see we're warning in the browser you can't guarantee its authenticity, right? So we generate the cert on the Raspberry using a single command, making it simple to use. Okay. So if you use Let's Encrypt, skip to step 5. We're not going to do that. We're going to do this one. So you use the following command to generate a self-signed certificate. So sudo openSSL req-. So this is just going to create a new certificate and drop it into a Bitwarden folder for us. Right, so I think one of the things I think when we see this, right, so we're going to just copy it and run it and go, yay, we got it. You could easily create a module around how OpenSSL works, how to create keys, what keys are, you know, how they're used, right? There's all kinds of things that you could build around that one particular command. For our purposes today, right, we're going to run the command and hope it works. So that we can actually complete the actual project. But I really think there's always opportunities like that to me. Like we could have them, you know, have students find articles. We could have a discussion post on it. We could maybe expand it out to have them learn other ways. You know, how could we change this key, right? You know, what are each of these? What do nodes mean? What do days mean? What does a new key mean? What does key out mean? What do all of those things? You know, what do they actually mean, right? And you can build that as a potential, you know, assignment, lab, whatever, right? Module. Okay, I'm gonna hit enter, and we're generating the RSA key for 4096 bits. So the key is gonna be here. That's the private key. And that's the certificate that goes out. So during the process, you'll be asked to provide some additional details. OpenSSL will write these details to the certificate to help you identify whether or not it's a forgery. That's all the required questions to finish generating the certificate for your Raspberry Pi Bitwarden installation. So at some point, it should ask us, there we go, country code. Obviously, make up stuff. So, all right. So we created a certificate. Our final bit of preparation task is to create a strong Diffie-Hellman group. This is used to help improve the security of the device's SSL connection. So then that's another, like this whole piece here could be a whole nother assignment. understanding what that is, why it's important. Please note that this process may take a little while to complete. All right, so I'm going to hit enter, and I'm thinking we've been here about an hour. You guys want to let's take a 10-minute break. We'll let this run, and then once it's done, we'll come back and we'll then continue and finish up the lab itself. But I'm gonna hit enter, then I'll start the timer. And I don't know, it says it's going to take a long time, so we're going to let it run. We'll be back in 10, and we'll finish up the setup and configuration and see what we end up with. So I'll stop the video now, and I'm going to mute. I will see you back in 9 minutes and 40 seconds. Sorry, I'm here. Cool. So I think it just got done. And we can move on. Excellent. All right, so I always know it's supposed to take a little while. So then the next step, configuring Nginx, man, I can't get those acronyms right today. Now create a virtual host to allow proxy connections to Bitwarden. Okay. So then I guess it's still a command prompt. So we're going to do from here, we're going to remove what would be their default web page. Looks like from the command. We need to create a new configuration. So we're going to create a configuration page and open it up in a nano editor. Within the file, type the following lines of text. So we're going to redirect any traffic from 80 to port 443. All right. Next, we'll need to add a server block that will handle the proxying and the HTTP connection. So we're not using Let's Encrypt. If you were using Let's Encrypt, you'd have to change these places here, but we're not. So this is, I'm going to assume, goes under here. So server listen. Okay. Lots of code that we could dig into. We may need to change a few things depending on how we plan to use the Bitwarden server. If you're using a domain name, we don't need to. You need to replace the server name. We don't need to. For example, our server would be server bitwarden.pylif. Okay. All right, so this is the instructions will give you a way, like if you wanted to create your own, which is pretty cool. Once done, your file should end up looking like this, right? So let's double check that. So we got server listen, server return, brackets. I think we're okay. Copied it straight out, so it should be all right. Once you're done, Control X followed by Y. Control X, Y, enter. Now what we need to do is restart the service, right? So similar to the, what was it, the SSH yesterday that we had to keep restarting every time we made a change to the config file. We're going to restart Nginx, and it should, hopefully, right, use the Bitwarden config file. Okay, so if that worked, we should be able to refresh this page. When we get the warning, hey, it's not a verifiable certificate. Oh, nice, good, awesome. Without restarting, let's see. So I am, so this is off of my back gateway. Must have messed something up somewhere. Anybody else getting in bad gateways? Anybody else get it to work the first time?
Yeah, I got it to work.
Okay. Most excellent. Just trying to figure out at what point did I miss a step? So yeah, should be HTTPS forward. So we have some other issue here. Oh, it's still, I kept on going down. I need to go up. My bad. And you do what I did, just copy everything over. We didn't have to change the server name. We're just using the IP address. We're not using a.
No, I just copied everything.
Okay, yeah, that's what I'm thinking. I'm going to assume that difference and this difference don't matter. Yeah, it just copied right over. I done broke it.
I didn't see your step one. Did you do a step one? Just removing the old, I guess, default file?
Right here.
Oh, yeah, you did.
So removed it, edited, copied those two pieces over, saved it, restarted, went back and double checked it again, restarted it again. So that's not good. So when we did this. Trying to go backwards, like, so we did this is command is right there. That information I did right here. The next command up. Right there. And they're in the same spot, right? Make sure that, let's see, SSL certs, NGI, next bit warden.crt, bit warden.key. So everybody here, there's only the one person that has it working? Does anybody else have it functioning? And then my next question is, did way up at the very beginning of the container where it told us Vault Warden, did you use Vault Warden or Bitwarden? Mine says starting.
I followed yours. I use Vault Warden.
Okay. So does on your Portainer, is it in starting? Like, is it starting there? Is it, I'm curious if there's,
Oh, yeah, it says it's starting. Do you want me to refresh the page?
I'm just wondering if it like, does it, oh, now it says running. Okay, so mine never got out of starting before. So I'm wondering if that had something to do with, maybe not, I don't know. I'm guessing at this point. So then I'm gonna go, now that I've got that container running, I wanna start. Yeah, it doesn't like me. What did I do wrong? Okay. Trying to
The
think
only
if,
thing that I did different, Kerry, was
Mhm.
in seeing step number 6, they have everything in one config file. Rather than copying those two boxes, I copied the last box in step number 6. It
okay,
should be the same, but I really didn't check to see if there's any difference between.
all right. Let's I mean, so I'm gonna bring that up and let's wipe all of that out. Control K. All right, and then Control C, so then Control X, yes, enter, then restart. This doesn't like me. What happened? Let's try one other thing. I don't think it's gonna help me, but I want to see.
I can share my window if you want, and you can walk us through.
Okay, let me try this one last thing and then. Okay, yeah, I just wanted to double check. It's getting the same thing whether I'm on the Raspberry or running from another browser, so it's not. Okay, I'm gonna stop my share. So you should be able to share your screen if you want to show us.
Sure, I'm about to, yeah.
Nice. So I'm not seeing in the chat if anybody else has gotten this far, if you've got it working or not working. Trying to get a sense for where everybody's at. But interesting that.
No, do you need to? Do we need to create a new account here, or?
For those, I think we created, I think, yeah, the instructions kind of continue on from there, right? So if you, trying to figure out where to drop my instructions, I think they're behind your screen right now. There they are. All right, so right after that, right, access it, create an account, right? So number 2 is create an account. your passwords didn't match.
Let me try it again. Ah, there we go.
All right, so now you have a Bitwarden password vault. Awesome. So that would be that's step number 5 is that piece there. The next one says enable the Bitwarden admin panel. Now that you create an account, you can generate an admin token. The admin token is what you'd be using to access the Bitwarden admin panel. This will require us to make changes to your Docker container configuration. So within the admin panel, you'll be able to view all registered users and delete them. You can generate invites for new users, even if you have disabled the functionality. So this actually looks like you could actually use this as well, obviously for multiple people if we have users, right?
Mm-hmm.
So that's pretty cool. So then to generate an admin token, there's a command. If you just continue the instructions, there's a command, generate the admin token from the terminal. It's using OpenSSL again.
Okay. And what's the command? I don't see that.
It's OpenSSL.
Ah, I see that.
Yeah. RAND -base 64 space 48. Awesome. All right. So then now that we've got the token,
I guess they want us to save it. So I'm going to save this in Notepad.
and when you feed this to the new admin token into our Raspberry Pi Bitwarden Docker container. So it's possible to do this using the Portainer web interface by modifying the command line to feed it in. So then in Portainer, so you go back to Portainer.
Okay.
And you click on the container itself, the Bitwarden container, and it should take you to the information page. Yep. And then at the top of the next page, you should see a duplicate edit, right? So the top right button, there you go. And you click that button. And then we're looking for advanced container settings.
Right here.
And then add environmental variable. All right. You should see 2. Hold on, let's see. Underneath the heading, you'll see ENV. So then you click add environmental variable. So there's a button right above, yeah, right there.
Okay.
And then in the name text box, you do admin token, all capital letters with a underscore, admin underscore token. And for the value box, you enter the admin token you want to use. So it'll be that big old string that you copied.
Ah. Okay.
Okay. And then once we have that, you go back up to deploy container. So it should have asked you before Portainer will update Raspberry Pi Bitwarden. You'll see a message below. Should have been like, are you sure you want to do this? Replace it.
I did.
Okay, I missed that part. So we're not using the command line to set the token. So accessing the Bitwarden admin panel. So then now you would go to your IP address /admin. So instead of going to the, yeah, so there, and then you would put admin. And then you get your token.
Is that same
That's
number?
the same copy thing that we did, yeah.
Let me just.
And now you are in the admin panel. Use these pages to manage your users as well as configure Bitwarden settings. So this is where you would actually set, any kind of settings in the background. So that's awesome. Just kind of looking to see what it's got here. This is pretty neat. Once you've created an account and set up access to the admin panel, you can disable the user registration menu. This means only users you invite personally will be able to create users on the Bitwarden vault. So to disable user creation, you'll need to load up the admin panel.
Right here?
Then you're going to go to general settings. Yeah, let's see. General settings, allow new signups.
General setting.
And then unclick allow new signups. Next one. Little box right in the middle.
Oh, right here.
Yep.
Okay.
So that's gonna make it where you can invite people to put their, to use the Bitwarden, but nobody, somebody on your network couldn't just get to it and start adding stuff to it.
I see.
So to confirm the settings, you can scroll to the bottom of the page. At the bottom of the page, you click save. All right. And from that point, it's the end of the lab, right? So you've created, I didn't get it created because I have some kind of weird, I don't know if I missed something along the way or something, but, and I haven't heard from anybody else if they got it working or not working, so I don't know. I'm hoping somebody else got it functioning as well. But at this point, like you just built on the Raspberry Pi, you built a password manager, right? That you can use as a password manager. You could have, and we didn't do this today, but you could have used like Let's Encrypt to get an official third-party Ssl certificate. You could have used like in my place, I would use a dynamic DNS setting to point to my router, and then I would use port forwarding to my computer. But I could have a password manager that I control. It's on my network, running on my system, which is pretty cool.
That's awesome.
Yeah, I think it's pretty neat. I wish, I don't know why mine acted funny. Mine just and that's one of those. It's one of those things, right? So I'm sure we can troubleshoot it and figure out what's happening with my particular machine. But I don't know. I think it's pretty neat that we were able to. We at least got one of you got it built. That's awesome. So I'm gonna take that as a success. Bitwarden check. I'm probably I go back through it and probably find some weird place where I missed something in the process, but I think that's, I don't know, I think it's pretty neat. So I've got it running here. I mean this whole idea of the containers, right? I think I'm intrigued by that. I think it would be really neat to be able to have that, or even have a Raspberry Pi on a network, and you'd be able to, as an instructor, throw up a website really fast and have students access that inside the classroom. Throw up a capture the flag, a box that they can do something with, or eventually probably throw up like a honey hole, or any of those kind of things where you can start to show some of these really cool techniques. You can throw up some machines that have a bunch of ports open and they can scan, and you can have the ports available, and they can, right? And then you can just shut these things down when you don't need them. But you can run all those on a single Raspberry. Like it's not, I don't have to, I can configure each one individually and run them in containers and just launch them when I need them, kind of a thing. So pretty cool stuff. I'm glad we played with it. I am a little disappointed that mine didn't function the way it's supposed to, but I think it's nice that we were able to see, you know, a working unit from the instruction. So I think that either I just missed something, or I don't know, there's just some kind of weird anomaly, which I think we're going to run into regardless of what we do. So I think for me, and the same thing I tell my students is, well, let's start over. Let's go back and let's see what part we missed. Right? That's just part of IT. So awesome. That's great. Excellent. Okay. Let's close. I'm going to close down my. Let me exit out of this. I'm gonna exit out of my SSL connection or SSH connection to my Raspberry. I'm going to go ahead and close the terminal window. I'm going to close this window. I mean, obviously, Portainer and Docker and Nginx are going to still be running in the background. And I can come back to those and troubleshoot why I'm getting the bad gateway error. In fact, I wonder, Nginx 502, that gateway. So maybe my redirect's not working. If anyone reading this, it's probably the case no such file directory due to the wrong path in the Nginx server box. So I think, yeah, so it seems like there's a path problem. It's not either it's not reading that config file or I'm getting redirected somewhere. So I'm thinking it could be I just missed something along the way. I think it's more likely that I made a mistake than it just doesn't function. But so I think I can. That's something I think I can troubleshoot. I'm not going to troubleshoot it now. I think we should move on to another cybersecurity Raspberry Pi related thing. I hope for those of you that tried this, that you were able to get it to function. Okay. Cool. Any comments, questions? Do we want to pause here? I'm gonna just kind of move on to the lab that and we're gonna move on to the Bluetooth lab and see if we can't make some things happen there. I'm gonna close this piece down. It's still running on my machine. I'm not, I'll be able to, like I said, get back to it, try to figure out what piece I did incorrectly along the way. There's lots of moving parts to that lab, so it's completely possible. All right. Okay, no worries. I also am going to exit out of my VNC viewer. So I don't have anything running that doesn't need to be running. I should turn off Teams. Okay. And I don't need to be making a backup right now. Awesome. All right, next. So it's in my clock, it's 11:35. That gives us about an hour and 25 minutes to check out this next lab. The next lab we want to look at is 4123, Sniffing Bluetooth. All right. So the idea here is we're going to configure the Raspberry Pi to detect and display information about the Bluetooth devices that are in range. This is an awareness building lab that will help students understand the nature of wireless hacking, processes and requirements, and take on a hacker mindset to think like a white hat to help secure IoT security devices. Right. So this is a I think a lot of these labs are awareness labs. Like once you do a lab like this and you can see what's possible, it's only take a different perspective. Right. So let me look at we're going to need to fire up our Kali to get DHCP up and running. That's if your Raspberry, your Raspberry should be on its own. And then we're going to SSH to it. Okay, so let's do that. Let's take this and put the lab there. Here's the Oracle VirtualBox. Here's my Kali Linux. My Raspberry Pi is currently unplugged from the network. I'm going to plug it in to the lab side of the network. I don't know. I know somebody tried to reach out to Dweet, but Dweet.io, I can't, like, we're still getting page isn't working. So I don't know if that's normal, but I think it is. So on our Kali Linux box, we're going to log in root and GOR for the password. And then from the material here, we're going to run the script that gives DHCP up and running. All right, then it says determine the IP address of your Raspberry Pi as was done in previous labs. So you can do the fping, those kind of things. I'm going to take the easy way out and fire up PL app launcher. And to find the, it should be 19, like it should get the same IP address. Oh, 19 was my other box. 20. Okay, so 203.0.113.20. Okay, so perfect. And then open a web browser. So then open a web browser and on your host PC and navigate to the IP address. So we are, it has us using PL app. Now we're going to go to PL app and open a terminal window and run these commands. All right, so okay, we're back. Let's bring back up. I'm going to relaunch PL app launcher because I have moved my machine to a different network. I am going to unplug and replug it in. Hopefully it will then ask for a new IP address and hopefully show up on my list here. Now, if that's not working, then I may have some issue with this. With this brand new switch. It didn't. Oh, it works perfect. Okay, good. So, like, please don't be a brand new switch that I bought. All right, so now I can see that I'm on 172.17.69.135. Okay. So I'm not running VirtualBox. So this is something that I don't know. There is some kind of conflict because, you know, no issues until we run that. And then as soon as we run that, yesterday afternoon, I don't think we had issues because we weren't running. We didn't need to run VirtualBox yesterday afternoon because we were doing the bit Warden stuff. And because we needed the main Raspberry Pi to be on the internet, the PL app, I put it on the regular network and we weren't running the DHCP. So I truly think the drop issues are related to DHCP and, you know, possibly playing with my network adapters, right? And maybe causing me some issues.
So, Kerry, the reason why we're using the DHCP service just to have it on the isolated network, but in theory, we could use, if you are on your home network, you can just run the PL app on the same subnet.
Yeah,
and that's no problem, right?
Yeah, that's what I'm doing now.
Okay.
So what I've done is I just moved everything to my regular network. So now I don't, like, if you're doing this in a lab, like, you know, and you've seen the little drawing that we have, I think that makes sense in a lab environment, right? And it's not likely that your students are going to be streaming with Zoom while they do that. So it's not like we're going to run into that problem in a classroom environment. Like, we're trying to do I was trying to do the classroom environment and streaming that, but I think that DHCP causes enough conflict that Zoom just freaks out. I think that's what happened.
One question: if we set up our labs and we just run on an isolated network outside your school network, that is, it's okay. you can just run the Kali Linux as a DHCP server and put all the PL app Raspberry Pis on the same subnet.
Yep.
So you should not have any problem, right?
Yeah. You could also
Mhm.
skip using the DHCP service on the Kali Linux box completely and just have a Raspberry Pi running a DHCP service on that lab network.
Okay, yeah.
Yeah,
That's-
zipper
that's
by
probably
itself,
also, yeah.
really super tiny, right? And and it could do DHCP. It could run, it could do everything that you need it to do.
Yeah.
So
And
that
just add Kali Linux on machines,
right.
whatever you need. Okay.
Correct. Like, and we're using the virtual box. Like you could run. So the other thing I'm thinking is, well, maybe like VMware Workstation, maybe it won't conflict as much. Maybe it will. I don't know. I haven't tried it. That would be another option, right? And just run Kali Linux, and we're running it in a virtual machine so that we can attack the Raspberry Pi on the network. So as long as we know which Raspberry Pi we're attacking, it's not a problem.
Okay.
And I know, like, it sounds like you have I have a sandbox lab, so I can do whatever on that lab, and it's not going to fire off any kind of IPS or IDS kind of alert or problem or any kind of,
Yeah, me too. We are on an isolated network.
Yeah.
For
So there are, but there's, in the last class that we did a couple of weeks ago, there was a lot of high school, they don't have separated classroom, they don't have separated labs, right? So they're running in a real tight, real restricted environment. So we're trying to come up with ways of doing it. So the way they built the lab here is for us to keep the, quote unquote hacking components off of a live production network to avoid problems. Of course, in my network, doing that causes problems. So I'm going to go with this. I have changed and moved from a graphical standpoint. I like to have pictures. I like doing pictures. So I just want to make sure that we all understand what just happened here. And especially if you're going to, if you have to do this, you're doing this, live like I have to do. Like in this case where if you're streaming it, you're going to want to be able to avoid issues, right? Let's see if this comes up the way it's supposed to. So we got to figure out.
Hi, Kerry. I got a question. It's like I lost the Jupyter notebook, the web link, and somehow. So how can I get back to the Jupyter notebook to run with the PLL?
So you ran your launcher, right? Or you don't
the launcher. Yeah.
It runs, but you don't have a connect button. Is that what you're saying?
Yeah, I have I have a connect button, and I see I see my Raspberry Pi with the PLL, but I missing the web page with all those instructions.
This one here? Okay, because this is actually just a PDF from the actual class. So if you go into the class itself, 4.1.2.3. In fact, I don't know if this will get you where you need to be, but I'll put it in there. So this is a PDF of the lab. So the lab it's not a live, so if I click on connect here, right? Like if you remember in the IoT course, right, there's a ton of material in there, but in this particular course, there's only that one lab in chapter 2 where we actually do commands. If we read through this lab right here, it's all terminal based stuff. So what they told us to do, they literally said, go use the PL app to get to your machine and then open up a terminal session. Right. So you could do that, right? Or, right, you could also open up a normal terminal session on your regular computer and SSH to, or was it Pi? I think it's Pi. Let's see if it is Pi.
By the way, you're not sharing your screen.
Okay. Thank you. It's just my luck, right? All right, there you go. So and I think that's going to be the quickest, easiest way, right? In the previous lab, we had done a whole bunch of like configurations, right? We had told it to turn on SSH and turn off SSH. So my thinking is if you wanted to try to terminal to it, I'm wondering if this is going to work, right? And the username is pi, and I know my IP address is, that's my IP address. So yeah, so it failed. Okay, it failed because now I've got that whole known host issue. So I've got a known host issue where I've already used 135 as a host. So my next step is I need to go now I'm going to run Notepad real quick. Type it out on Notepad. So I'm going to run Notepad on my computer real fast, and I'm looking right here, right? This is where I need to go. So File, Open. I'm already in that folder because I did this before. So known hosts, and then I'm on 135, so I need to get rid of this line. So this is the known host file that keeps track of all of the hashes for your SSH connections. I'm going to go ahead and save that, and close that. And now when I try to connect to my, I'm using, in the background here, I'm just connected to PL app and I launch the terminal. That's the easiest way to do it, right? This here is if you want to try to just use the terminal to do the same assignment. I'm going to log in as pi. Right, so now I'm logged in to the terminal for my computer, or for my PL app, right? From the terminal. I got a terminal here and I got a terminal over here. Okay. I'm going to try to run this with this terminal, because if we can run it with this terminal, there's a good chance that we can run it on a regular Raspberry Pi. In fact, I should try that. So I'm going to open up another terminal window, and I'm going to sign into my regular Raspberry Pi, the Raspberry Pi that does not have the Cisco, right? So I've got two of them here. I've got WASTC and I've got bananas, okay? So I'm going to run these commands on both of them as we do this lab, because I want to see if you can run this lab on a regular Raspberry Pi without doing anything special, okay? Because then that means this lab can be, you could take this PDF and take it into your classroom and use it, right? And show Bluetooth, sniffing Bluetooth. Cool, right? So, right, following the normal directions, right? You're going to go to your PL app. So you're going to launch your PL app. You'll connect to your machine. You'll get to a window that looks something like this. You'll click on New Terminal, and that will open up a terminal session on your Raspberry Pi. That way you can avoid the SSH. You can do all, that's the easiest way, and that's what the instructions tell you to do, okay? In my case, I'm using SSH to both of these, and I'm going to do it on two different machines. This is the same machine. This is the same, this machine, right? WASTC W3, WASTC W3. Okay. So the idea here is this, again, this is a awareness building lab. We're going to show students kind of how some of this stuff works. Like I said before, we've had some luck with it working and some bad luck with it not working. And we will probably end up with a mix of success and failure. We do not need to have any pre-work done on this. If you haven't done anything or you're behind in labs, you can pause there and come right to this lab and do this with us. This doesn't depend on any other lab, okay? So I'm going to start with on the WASTC, my PL app computer. So the first thing, right, set it up, DHCP, find your address, open up the browser in Kali Linux and navigate to they actually had you go in the browser in Kali Linux. So they're doing, they're giving you to the IP address, which is going to open up the PL app. And then right from the PL app, you want to run a terminal window. Okay. And then right off the bat, they want us to verify and activate the Bluetooth interface services on the Raspberry Pi. So let's see what's going on here. So RF kill. Lists. And this is supposed to check if the Bluetooth interface is blocked by software. Okay. Software block, no. Hardware block, no. Software block, no. Hardware block, no. So wireless LAN is not blocked. Bluetooth is not locked. Okay. If the Bluetooth interface HCI is blocked, this is it right here, HCI 0, then we need to do an RF kill unblock Bluetooth. So if you have blocks here, then you need to do RF kill unblock. You shouldn't at this point. We haven't really done anything else with this, but just in case. Then the next thing we want to do is we want to see the status of the Bluetooth service, right? So that's going to be this system CTL status Bluetooth .service. All right. And you can see that it's active and running. Okay. The green on the response there. If your status is not active and running, you can run this command here, system STL start Bluetooth service. So, which we don't need to do because we have mine's running. I am going to jump over to my regular Raspberry Pi, do RF kill list. We see this not blocked. System CTL space status space Bluetooth. So I'm doing all the commands twice to see if this works on both machines. And we can see active running. I got some extra stuff going on down here. Q, got a Q to get rid of that. Okay, so I got some extra stuff going on. I'm not yet overly concerned here, but we'll see. So, and that's E and D. We don't need to start the service because they're both running. E, use the HCI config HCI 0 command to display the status of the Bluetooth interface. Okay, so HCI config, right? HCI 0. All right. And right here we can say it's up and running, right? We're looking at that piece right there, up and running. Okay. We'll do that same command over here on the other box. Hconfig HCI 0. And on this box, it is also up and running. Fair enough. If the HCI interface is down, right? So we can run the HCI config HCI up. So what we're doing, what this first part is, verify that you have Bluetooth, verify that it's not blocked. If it's blocked, unblock it. Make sure that it's up and running. If it's not up and running, start it. If it's up and running, and the status, and the status isn't up and running, then how to turn on the Bluetooth connection. Okay. So if you haven't really done anything with your Raspberry before this point, it should be on, it should be running, it shouldn't be having issues. If for some reason you turned off Bluetooth, for some, I don't know, for whatever reason, then this, this first section would help you get the Bluetooth back up and running. All right. So at this point, on both of my machines, I've got active running, up and running. Active running, up and running. Part 2, using the CLI to detect and display information about Bluetooth devices. From the command line, we're going to use the command Bluetooth CTL to launch the Bluetooth tool. Okay, so Bluetooth CTL. And then it dropped into, you can see there, I don't know what these extra words are here, but. So you should have been dropped into this Bluetooth hashtag prompt. Let's see if that works on a regular. Agent registered Bluetooth exclamation point. So it does, it works on both so far. Okay, enter the scan on command to start searching for nearby Bluetooth devices and scan off to stop it. Okay, so I'm on the WASTC machine, scan on. Nice, no default controller available. That's awesome. Let's see what happens over here. Scan on. All right, so that's my regular Raspberry Pi. Trying to see, I didn't miss anything, did I? So did I miss scan on? So we're going to scan on my, it's so good, right? So good. It's right there. We just talked you through it. That's the device. It's listed. So on my PL app, I'm curious, did people get the same kind of thing here? Did the PL app actually give you a no controller available, or did you get like I did on my, right? This is on my regular Raspberry Pi. It's showing me all the different Bluetooth things that are available.
I am on the regular PL on the PL app. And
Okay.
I got the devices.
You got devices. So there's something like literally like we went through this whole thing, like, all right, RF list, nope, it's not blocked. Status, it's up and running. Here's the device itself. And then it's like, I don't think so. But oh, wait, so I'm going to exit out because I saw something weird when I did this. Like see, connect to Bluetooth HD. What is that? I think it's not, my machine is not, that one's not connecting for some reason. I don't understand why that would be. Right? To Bluetooth, device. I think maybe, I don't know what that's doing. If we hit enter, it doesn't do anything. If we do scan on, it's like I can't see anything. I think it, all right, okay. This one working great, right? I'm seeing all kinds of stuff, and as things change, that's perfect. I love it. Now what I'm concerned with is Bluetooth control commands, connects. Let's see the connect command. Yeah.
It's not because did you shut down your DHCP server? Maybe?
No, the server's not running, and I'm connected to it via 135. Like I'm connected right up here. I'm connected.
Oh.
And these are commands running. I'm SSH'd into the box, and I'm running those commands from here. The other thing I'm going to try, is, all right, so over there, we're good. If I do blue, you can't see what I'm doing right now because it's on another screen. Interesting. Okay. This is me on the PL app, right? Running the way it told us to connect. This is me running as Pi on my through an SSH connection. This is root. So when I connected to the terminal from PL app, it connected me as root. And as soon as I hit enter, it functions, right? Works perfectly fine. Over here, I'm logged in as Pi. And when I try to do the Bluetooth control, it doesn't let me. I wonder,
Probably you have to do sudo. Or
I'm
something,
wondering, that's what I'm gonna try, Bluetooth.
because I'm using the PL app from the terminal, and yeah, it's like
Okay, that did do it, right? So I had to sudo that. So there was some kind of permissions issue with me connecting right over here. It wasn't giving me access to the device, to the controller. But then when I did it as a sudo, it gave me the controller and started scanning devices. Okay, so sudo, if you have that same problem, sudo Bluetooth CTL, and that gives you the permissions to connect to the controller, which would then do the scanning for you. Can you see, here's the scan that's running. These are the same machine running the same command, right? Two different windows. This one's running as root, this one's running as pi, this one's running as sudo. Root doesn't need to run the sudo command. And then on my regular Raspberry, this is my regular Raspberry, I'm logged in as Carrie, which is a sudo user that doesn't require me to type in a password. Okay, so I've got it running 3 ways. I just moved out of the way. There we go. Okay. Let me move this one back over here so I can watch it going. Okay, so here's back to the lab. So we ran scan on. We're on part 2B. Scan on. You can see it scanning stuff, and then they want us just to run a scan off. Okay, so scan off there. Hopefully it doesn't keep firing more stuff. Scan off. Awesome. Failed. Doesn't want to do it, but I'm in the. Is this still my Pi? That's my Pi user. So scan on works. This is inside of a. Let me highlight this and see if it moves on us. I'm going to come over here to my other box and I'm going to scan off. All right, it continues to move, right? So this one. So I went over here, and when I hit scan off, controller discovering, no, discovery stopped. That's what I was expecting it to do. On my bananas one, discovery stopped, but it keeps on trucking. That's interesting. So I'll leave that there. See if it moves up the list. And then you can see here, it told me it wasn't going to stop. I hit scan off and it says failed to stop discovery. And this one, I believe, again, I think this is a permissions thing. I think this may be a permissions thing. Me logging in to the PL app using SSH. Did anybody else have that issue? If you're logging into the PL app server. This one here, I'm logged into my, okay, I'm logged into my regular Raspberry Pi. Okay, and right here, I'm logged into the Raspberry Pi. I'll put that terminal up here. Maybe I won't. Oh, that's a terminal session, not a browser session. Okay, so I'm still, and this one here is the weirdest way of doing this, right? Because in the instructions, they have us go this route, right? And this route's working perfectly fine. So I don't have any issues with that one. Logging into the PL app machine with SSH using the Pi user, I think are running into, I definitely am running into permissions issues because things won't start, won't stop, all that kind of stuff. I'm gonna abandon that one.
But I think if you see the instructions on the PL app, it asks you are logging in as root.
Right, and that's what I was
No matter
saying.
what, yeah. So
if I try this as root,
Yeah.
I don't remember what I said here.
Because probably to do those commands, you had to be root.
Yeah,
And-
so
And
yeah, so I'm gonna not try to push that the SSH version because I have the terminal version on the PL app that works perfectly fine. We're using root, right? This is root.
Yeah.
Okay. All right. So we'll continue going back and forth. Yeah, I just got to delete for all the scanned devices because I just stopped the discovery and I think there's a timeout. So then it gets rid of all of the devices that it saw. And then you see that on my bananas one as well. So as soon as I stopped it, like here's the changes that I saw, and then we're going to get rid of it. And I think that's just because we turned off transmission, like we're not talking to it anymore. And then it's like, okay, my timed out and I'm going to delete all those items. Okay. So it found, wow. I found my watch, but my watch is in the other room.
well, I didn't even know that my toothbrush was Bluetooth when I did
Oh my
it.
gosh. It's really, that's awesome.
I didn't know. Now I have to check.
You're gonna like, wait a second, I got a vulnerability in my house. It's my toothbrush. All right, so we ran 2B, scan on, scan off, right? And you know, my discussion, it just, I hope you don't mind. I'm just kind of bouncing back. I'm trying to understand what's going on. So I logged in SSH as the Pi user. Okay, even though the Pi user has pseudo capabilities, we're running into permissions issues, right? But on the PL app, when you log in through the terminal, you're actually logged in as root, right? Right here, you're logged in as root. So you have, I think there's not a permissions issue. Now, over here on my bananas computer, I logged in as Carrie, which is the root user, right? It was the user that I established when I created the operating system, and I'm not having any permissions issues there. Okay, now to B, turn on the scan. We've all seen the scan. Turn off the scan. We've all turned off the scan. Now info from a MAC address, right? So obtained and deleted to obtain detailed information. Now my problem is I think all of my stuff has now been deleted. So what I may want to do is I'm going to run a scan on. I'm going to give it a couple of seconds. I'm going to do a scan off, and then I'm going to run an info on one of these items to see what's going on. Like I want to look at this one, right? My sense. Okay, so let's do that. I'm going to run a scan on. So I'm going back to 2B, scan on. I see it there. Scan off. Okay, and then I want to do info for, I don't know if it's going to let me copy that or not. No. So CV colon 64. Hopefully it doesn't get deleted before I get done typing. IP colon D8. This is why I don't like IP version 6, by the way. So much easier just to type numbers. Info on that. Sense is not paired, it's trusted not, it's blocked no, connected no, legacy pairing no, vendor UID. Like we could look up this to see if we can find some information about it. And then there's a serial service data key there, right? So not a lot of information that's going on there, but it is kind of telling us what's, you know, what it can find out. And then it wants us to, okay, so it wants us to then run the command. I'm jumping down to part 3. There's some information that, you know, the students need to look through and kind of get some ideas there. I'm going to run down to paired devices, paired dash devices. I don't have anything paired. And then I'm going to try to, I'm going to do an up arrow, and I'm going to try to pair to my sense. Attempting to pair. Oh my gosh. It connected, but authentication failed. Okay. So I didn't get a successful pairing, but I got an attempt at it, right? we could grab one of these other devices. There is what's that? So I'm curious. This is my is there a diff config? Oh, that's it. B827. Did it find B8? Oh, wait, that's Ethernet. That's the Ethernet controller. I'm wondering if one of these is my that's the controller right there, B827. But it's not seeing it on the scan here. I was wondering if I could connect my two Raspberries together. So I'm thinking out loud. Sorry. What's the same name? Although WLAN has a different number and the Ethernet has a different number. So I'm wondering if they all start with B8. I don't see any B8s here. Do you? No, I don't. Okay. So I tried to connect to my Sense. That was the first thing we tried to connect to. Let's I'm gonna go back to my machine here. Let's do scan on real quick. That's enough. We can scan off. We're gonna go to info. Actually, we're gonna skip info and go right to just connect. I'm gonna try to pair to something different here. See, just see what we get as a result. And I think this is where you're gonna get all kinds of craziness all over the place. So 2C colon AA colon 8E colon 42 colon 57 colon 680. Not available. Did I spell it wrong? 2C AA 8E 42 57. So that's not going to work. Let's try a different one. I'm just going to try to see if we can't find something that would accidentally connect. I'm going to mute myself for a second. Okay. I'm going to grab a pair of headphones from, well, my daughter's going to grab a pair of headphones. We're going to see if we can. Thank you. So we're going to do, so we got scan, scan on, and we scan on, and then I'm going to turn on. All right, so I got my headphones turned on. So this was a new one, but I think the timing of that is a little, that or it just picked it up right away. See if another new one shows up at all. And these are pretty close. They're pretty close. You can also, I think there's a little bit later on, you can actually try to turn on your Bluetooth phone. There's a new device right there. So we're going to try that one. So let's do scan off. And, oops, I should spell it correctly. That'd be awesome. And then we're going to try to pair to that one. 7F colon D7 colon 59 6. I'm going to try the other new device that showed up there. So it says connected, yes, or blue error connection attempt failed. Device is not available, which is not. Oh, I wonder if that was my daughter's headphones. She had them on. So we're going to try to pair to that first device that I saw up there. This one, this 5032. 50:32:37 B0 B0 8F B9 8F B. Bingo. Sorry, can't help myself sometimes. Oh, come on. I was really hoping it would find it. I'm going to turn scan back on and see if, try one more time. I'm trying to see if I can get it to connect to something real fast. So new, right? There's a new FE one right there. I don't know what that is. All right, I just turned my headphones on. Oh, I know why it's not seeing anything. Because it's connecting to my phone. So let me disconnect that. So Bluetooth is disconnected. I'm surprised by the number of Bluetooth devices that are showing. This is a duplicate. There's lots of duplicates in here, it looks like, but still. I can't think of that many devices that I have here that would be. Well, we've got 3 Raspberry Pis on the desk, so it's probably what's going on. So there's some new devices there. Oh, these are all redoing. They just deleted them all, didn't it? 32 BD, was that one from before? That one right there. And I wonder, this looks like it's maybe a decibel strength. Kind of interesting. So I'm hoping to see something different, but these, those are all, they just redid everything. So it's all new. All right. Cool. Let me. So this is where you never know what you're going to get, right? So paired devices, tried to pair something, right? So we discovered device, they act like, well, yeah, it's going to connect. No, it's not. Paired device there. There's a paired device, and then you have a connect, right? So, well, paired, attempting to pair, paired, yes, pairing successful. I never got a pairing successful. I got a connected, yes, but never got a pairing. Okay, connected, and then discovering, attempting to pair, connected, yes, failed to pair. I've got all failed to pairs. Yeah, so this is it. Like, so the idea here is that you have all of the students have all of these to attempt, right? And there's lots of duplicates. So the kind of idea, you know, write them down and then see if you can connect to any of them, right? And can you connect to them? And then what are they? If you could connect to them, you could also do info on each one of them and try to get more information about them. For example, I was trying to pair to that one, but we never really ran info on it. I don't know if there's any additional info here, right? Doesn't really tell us anything about it. Right? Manufacturer data, so I'm wondering. And then, oh, what was the other one we tried to get to? This one here, the 7F one. Right, so we're not pulling a lot of data for that at all to figure out exactly what's going on. I think we could probably also, so now I'm curious, I'm just, as I'm trying to discover things. So part of this lab is this like awareness lab, but there's a ton of, right? All of this right there is all, these are all the discovered devices, right? So doing an info on each one of those to see if they get any information about those devices. The other thing that I'm curious about, if I do a MAC lookup, so if we look up MAC lookup, right? So the first 6 digits are supposed to, you know, kind of give you a clue about who the manufacturer was. So I'm curious, will this even help us? Locally administered address. Address designed by network administrator overriding burned in address. No address can be found using that MAC address. So that one doesn't have a manufacturer attached to it. 43 colon 2C colon C4. So again, we're kind of hit and miss. We're trying to find, same thing there. We're trying to find anything that will give us an idea of what the device is. This is part of discovery. We have to kind of work through these. So this is a, wow, that's a light bulb. I don't think I'm going to be able to connect to it, but I'm going to try now that we know that it's a light bulb. So, right, so info on, what are we looking at? 2C colon AA colon 8E colon 42 colon 57 colon 6A. So that's that WHSCL1. Okay. So now that we know that it's a WISE and it's a WH, when did I miss it? WSCL1. It just gives us any, oh, it's not a light bulb. That's awesome. So that's my scale in the bathroom. Is we have a WISE scale in there. So that's the MAC address for that, and I don't think, you know, connecting to that I don't think is likely. But let's try. Oh, you got to be kidding me! That's awesome. Pairing successful. So now we go to paired devices. I connected to my scale. We got something working. Now you can see I'm connected. I am literally my Raspberry Pi on my desktop is connected to the bath scale in the bathroom. Somebody paired to their TV. That's awesome. Rsa got there. That's sweet. So that's neat. Yeah. So what can I do with this? I have no idea at this point. Like, we just go back over here to the instructions. So then it says using the command connect, right? Try to connect the Raspberry with some previously paired device. Oh, so we've already paired. I got paired to that device, right? And then I could connect to that device if I really wanted to try. But I'm paired right now, so I don't know. You know, again, what can we do with that? I'm sure there's other tools. Now that I'm paired, there's other tools that I could probably use. That that we could use to do. Again, I think they want us to be aware of this, but they're not really trying to have us break into somebody's stuff, right? But if the fact that I can pair to that device and I was able to find it, that's the other thing. And this instruction doesn't have going out and checking MAC addresses. I mean, the MAC addresses helped me figure out what I was doing with that one. There's still a bunch of other devices out here. So like I could try the OF:B9 : I'm looking for one that says Sony, right? Because that's going to be my, it's a bad format. What do they do? OF:B946. Oh, 0F, not OF. 0F:B9 46. So, because I know I have a set of Sony headphones. So Mac, no assignment to that one. I've already tried the 7F. Again, I think we may want to start keeping a notepad to figure out which ones we've already tried and which ones we haven't tried already. That 52, that, I swear, 52:EF:80. No assignment found. We've seen these kind of keep popping up. 43. Which one am I paired with? I'm paired with 2C. I thought I did 43 one already. 43, we'll do this last one and see, but it looks like, I mean, I've got a successful connection. Again, what can we do with that connection? I think, if you have other tools, you use other tools to sniff information. But at this point, of all the devices that are seeing on that this device is seeing on the network, it's not seeing my or I'm just not being able to pinpoint my Sony headphones. Apple. So I got a device that's an Apple. I think that's my kid's. Right? We won't mess with her. So she has she has all of her gears Apple. So one of those is her, or that one is. So anything that starts with 50DE06, that's going to be an Apple product. I'm surprised that this one doesn't show up as an Apple product. 52EF:80, it's really close. Anyways, yeah, that's a good laugh. So we're playing around with it, right? So we used it, we checked to make sure Bluetooth was on. We were able to get into the Bluetooth control, right? And then from Bluetooth control, we're able to scan and see what's out there. And then we're manually going through. This is a new one, 69FO. What's that one? Now I got to do it. Right? 69F04A. No information. I'm going to try to connect to that one though. Let's try that. Let's try to pair with that one. It just took a long time for it to see my 4A:AB:96:52. No, didn't like it. And then it deleted it. It's like, that didn't work. Oh, wait. I'm trying to connect from my, I don't know what that is. I'm wondering if I'm, this prompt here, right? So the prompt used to be different, right? Or no? The prompt used to be Bluetooth. And now the prompt is WHSCLI1. Because I'm paired with that device. So that's interesting. I'm wondering if that command, like that pair command, was me trying to pair my scale with whatever that other device was. Nice. So we got another somebody with the same scale. connected. So looks like we have so you've paired with the phone, but you couldn't connect, right? And that's kind of expected in this lab. Like some things are going to function. We're trying to kind of go through and discover, right? So I think part of the myth around cybersecurity is like, oh, you just click and you're done. Like that's not it at all. Like this is the kind of stuff you have to do, and you got to go through and you're kind of breaking it down by manufacturer. Now that I'm connected to my scale, what can I actually do? What could I connect? Like what could I don't know, what can we do with it? Like, can we connect to it? Can we pull data off of it? Can we, right? I don't know. Can we intercept things? I don't know. So yeah, so it's just, I don't know. It's an interesting lab. I think you're going to get, a wide range of success and failure on it. Some things are going to connect, some things aren't. I was lucky to find one that could connect. I think everybody, most students are going to have a half a dozen types of devices that they can try to connect and see what happens. I did turn off my cell phone, turn on my speakers. So so now that I say that, the other option you have, like if you have a Bluetooth speaker around, so I'm going to turn on another device. So there's a brand new device right there. So I think that's going to be the one I'm looking for. So then I'm going to try to pair to 1312 BF 29:93:4F. Attempting to pair. Again, I don't know if I'm doing this from my scale. I think I might be trying to do this from my scale, so I don't know if that's going to function in that. Because of the prompt there. The prompt has me concerned. So I got two new devices that popped up right there. So we got somebody paired with their Android phone as well. That's awesome. I'm going to exit. So FC 58 and 1312. So I'm going to exit out of this real fast. I'm exiting, and then I'm going to go right back into it. Oh, and what is going on there? See how it does a WCLI there? I'm going to bring this over and Bluetooth. So Bluetooth here, scan on. I think I heard my. Can you turn that power on? Turned off my. So, oh, look, Jam Classic right there. So I should be able to connect to that one. Pair. Oh, now I'm getting, here's my, that's crazy. I didn't get that information on the other one. Scan on. I have Jam Classic. That's a speaker on my desk, and the WHC15. That's my headphones, my Bluetooth headphones. So then we're going to try to pair to Jam Classics. FC:58:FA. So this is, I think, the one way you can get your students to get a success is to have, because these are kind of designed to connect. Oh, then it's not available. To turn it off. Turn it back on. I turn it off, and then I'm gonna. Interesting. I can see it, but it doesn't. Let me do the Sony ones. They're a little bit off the screen there. Sony is going to be 7445. 7445 CE 1A 0466. All right, so that's interesting that it sees them. I wonder, do we need to have the scan on in order for us to see these things? So I'm scanning. Yeah, it's not. So it sees them, but then it says it's not available. That's kind of a weird deal. All right. Cool. So at least I got one thing connected, right? I was able to connect to my WAS scale, right? Using Bluetooth. And that's kind of the idea of this lab, is just kind of have you see what's out there. Like I can see all the stuff that's out there and right, do some research on those things. I added in kind of using the Mac lookup, right? So I can kind of maybe get some ideas, and that's kind of where we found the WAS component, because oh, I remember that being out there. I thought it was one of the light bulbs. Because we do have a WAS light bulb, and it should, well, I don't know, maybe Bluetooth doesn't, it's maybe a Wi-Fi device. So maybe that's why the only WAS, the scale was there. But that's another thing that we can add to this whole mix, is that, right? Is that research and kind of figuring out what these things are. And then from there, they can figure out, you know, again, discovery, finding other pieces of, you paired to your sonic toothbrush. Oh my God, that's awesome. All right. So I don't know, I think that lab went good. Even if you didn't get a success, at least you saw some things happening. We've got multiple people that are got several really cool connections, right? Or at least they were able to discover things. Right, so I think that's pretty cool. And we have, like, there's 15 minutes today. I'm supposed to remind you, today is the raffle day. So you need to kind of head over to all those things that you should have some emails related to it or announcements related to it. I was told to tell you to make sure you read the instructions for exactly how you're supposed to participate and all those kind of fun things. I don't think we should try to stretch out anymore to kind of fill in 15 minutes. I think you guys can have the extra time, and then we'll just meet up at the designated time, which is 2 p.m. Mountain, right? So an hour and 15 minutes or so from now, we'll get back together and we will continue working. I think that was a great lab. I'm glad we got to see some connections being made. I've got, you know, several of you got connections made, and then the previous lab, I'm glad we got to see the entire process working. I'm not sure why mine particular one didn't work, but obviously it'll be something that we can troubleshoot later on. But good, we got 2 solid labs completed this morning. We'll come back and we will work on I want to jump into the port scanning lab, and then I'll take a look and see what the packet crafting lab looks like, and see if it's I think that may just be a Kali Linux thing as well. But I know the port scanning one, we're going to port scan Raspberry Pis, so that'd be good. All right, so have fun at lunch, and I'm just going to put on